we are going to do question number 7, part A. Show that cos x upon 1 minus sin x plus cos x upon 1 plus sin x can be written as 2 sec x. First of all, we will take LCM. When we will take LCM, we will have in the denominator 1 minus sin x, 1 plus sin x. So this will be multiplied by 1 plus sin x, and this cos x will be multiplied by 1 minus sin x. We can apply identity in the denominator, and we can write it as 1 minus sine square x. A minus b, a plus b is equal to a square minus b square. So it is 1 square minus sine x square, so which is 1 minus sine square x. Now we'll expand this. We'll multiply cos x by 1, we will get cos x. We'll multiply cos x by sine x, we will get cos x sine x plus cos x multiplied by 1 is cos x. Cos x multiplied by minus sine x is minus cos x sine x. We can cancel out plus cos x sine x minus cos x sine x. So we are left with 2 cos x in the numerator. In the denominator, 1 minus sine square x can be written as cos square x. Then we can write cos square x as cos x into cos x. So this cos x and this cos x will be cancelled out. So 2 into 1 upon cos x, which can finally be written as 2 sec x. Part B, solve the equation 5 cos x minus 4 sin x is equal to 0 for the range x is greater than or equal to minus 180 degree and less than or equal to 180 degree. So whenever we have equation in cos x and sin x, we change it into tan x. So first of all, we will take sin x on that side. So it will be 5 cos x is equal to 4 sin x. Now we can take cos x to the denominator of sin x. And we can take this 4 to the denominator of 5. So we have tan x is equal to 5 upon 4. Then we will take out basic angle alpha by taking tan inverse of 5 upon 4. So alpha is equal to 51.3. As tan x is positive, so we have to consider first and third quadrant. So in first quadrant, this is alpha, which is 51.3. And here, this is alpha, which is 51.3. We have to consider the range from 0 till minus 180. It means that we have to consider from here till here. And we have to consider from 0 till 180, from 0 till 180. So it means that we have to consider third quadrant for clockwise angles. So in third quadrant, it would be minus 180 plus 51.3. This is the angle which we have to consider. So it is minus 128.7. Then we have first quadrant. In first quadrant, theta is equal to alpha, so x is equal to 51.3. Minus 128.7 and 51.3 are the required angles. Part 2 of part B. Solve the equation 10 sine square 2x minus 9 is equal to 3 cos 2x for x is greater than or equal to 0 and less than or equal to pi. As we can see that here it is 2x, so we will be changing the range accordingly. We have x is greater than or equal to 0 and less than or equal to pi. So we will multiply this by 2. So this will become 2x is greater than or equal to 0 and less than or equal to 2 pi. First of all, we will take 3 cos 2x on this side. So this will become 10 sine square 2x minus 3 cos 2x minus 9 is equal to 0. Now we have here cos 2x and we have here sine square 2x. So we need to change this to cos square 2x. Then we will have equation in cos. So 10 into sine square 2x is equal to 1 minus cos square 2x. We are using here the identity cos square x plus sine square x is equal to 1. Minus 3 cos 2x minus 9 is equal to 0. 10 multiplied by 1 is 10 minus 10 cos square 2x minus 3 cos 2x minus 9 is equal to 0. We can write here minus 10 cos square 2x minus 3 cos 2x plus 1 is equal to 0. To make this cos square 2x positive, we can multiply the whole equation by negative sign. So it will become 10 cos square 2x plus 3 cos 2x minus 1 is equal to 0. Now, this is hidden quadratic equation. So we can take cos 2x as a. Now this equation will become 10a squared plus 3a minus 1 is equal to 0. So we can factorize it using middle term breaking. 10a squared plus 5a minus 2a minus 1 is equal to 0. 5a is common. 2a plus 1 minus 1 is common. 2a plus 1 is equal to 0. So we have here 5a minus 1, 2a plus 1 is equal to 0. So we have 5a minus 1 is equal to 0 and 2a plus 1 is equal to 0. So a is equal to 1 upon 5 and a is equal to minus 1 upon 2. As we took the cos 2x as a, so now we can replace a by cos 2x. So cos 2x is equal to 1 upon 5 and cos 2x is equal to minus 1 upon 2. As we have here compound angle, so we can take a is equal to 2x. So cos a is equal to 1 upon 5 here. And same we will do here. Cos a is equal to minus 1 upon 2. So basic angle alpha is equal to cos inverse of 1 upon 5. Alpha is equal to 1.369. As the range is in radians, we have to use calculator in radian mode. Alpha is equal to 1.369. As cos 2x is positive, so we have to consider first and fourth quadrant. So A in first quadrant is 1.369 and in fourth quadrant it is 2 pi minus 1.369. So it means that 2x is equal to 1.369 and 2 pi minus 1.369. So for x is equal to, we will divide this by 2, we'll get 0.685 and here we will get 2.46. For this one, alpha is equal to cos inverse of 1 upon 2. So alpha is equal to pi upon 3. A is equal to, as cos is negative, we have to consider second and third quadrant. So for second quadrant, it will be pi minus pi upon 3. And for third quadrant, it will be pi plus pi upon 3. So 2x is equal to pi minus pi upon 3 is 2 pi upon 3. Pi plus pi upon 3 is 4 pi upon 3. So x is equal to, we will divide 2 pi upon 3 by 2. So we will get pi upon 3. And we will divide this by 2. So we will get 2 pi upon 3. There are four values of x, 0.685, 2.46, pi upon 3, and 2 pi upon 3. Question number 8. F of x is equal to x squared plus 2x plus 5 for x is greater than or equal to 0. G of x is equal to 5x upon x plus 2 for x is greater than or equal to 0. Part A, Part 1. Explain why the function f inverse can be formed. For this, we will change x squared plus 2x plus 5 to completed square form. We will have x plus 1 whole square minus 1 whole square plus 5. We divide 2 by 1 and we write with x plus 1 whole square and then we take the square of 1 with minus sign. So we have here x plus 1 whole square plus 4. So if we draw this curve, we will have minus 1 here and 4 here. So the curve would be drawn somewhat like this, right? The domain is given x is greater than or equal to 0. It means that this part of the curve is to be considered. For these values of x, the function is one-to-one function. If the function is one-to-one function, then f inverse can be formed. The function is one-to-one function for the domain x is greater than or equal to 0. Part 2. Find and simplify an expression for f inverse of x. For this, we will consider y is equal to x plus 1 whole square plus 4. We'll make x the subject. Y minus 4 is equal to x plus 1 whole square. Then we'll take square root on both sides. So y minus 4 is equal to x plus 1 whole square root. This and this would be cancelled out. So we will be left with under root y minus 4 is equal to x plus 1. So we have plus 1. When will be taken on this side, it will be minus 1 plus minus y minus 4. As we have taken out square root, so we have to consider plus and minus sign. Is equal to x. So f inverse of x is equal to minus 1 plus minus under root x minus 4. Now we have to consider only the positive part, minus 1 plus under root x minus 4, as the domain is given x is greater than or equal to 0. Part B, Part 1. Explain why the function gf can be formed. For this, we need to find out the range of function f. If we'll substitute 0 over here, then we will be left with 5. So the range of function f is range of f of x is greater than or equal to 5, and domain of G is x is greater than or equal to 0. Now, the range of f is a subset of domain of G the function gf can be formed. Part 2. Solve the equation gf of x is equal to 4. We have g of x 5x upon x plus 2 and f of x x square plus 2x plus 5. We have to substitute f into g and we have to equate it to 4. So we have here x. In place of x, we will be substituting x square plus 2x plus 5 upon x square plus 2x plus 5 is equal to 4. So we will have 5x square plus 10x plus 25 upon x square plus 2x plus 7 is equal to 4. We will do cross multiplication. 5x square plus 10x plus 25 is equal to 4 multiplied by this whole, so 4x square plus 8x plus 28. So then we will take all these terms on this side. So 5x square minus 4x square will be x square. 10x minus 8x will be 2x. 25 minus 28 is minus 3. So now we will do middle term breaking. To solve it, x square plus 3x minus x minus 3 is equal to 0. X is common. X plus 3 minus 1 is common. X plus 3 is equal to 0. So x minus 1 and x plus 3. So we have x minus 1 is equal to 0 and x plus 3 is equal to 0. So x is equal to 1 and x is equal to minus 3. X is equal to 1 is the answer because the domain of f is x is greater than or equal to 0. So x is equal to 1 is the answer. Question number 9. Part A. A geometric progression has first term 3 and common ratio 1.25. A is equal to 3 and R is equal to 1.25. Find the sum of 12 terms of the progression. Starting with the 20th term, give your answer to the nearest integer. There are two ways to do it. One of the way is that you consider 20th term as first term and then find out the sum of next 12 terms. So for that, we need to take out 20th term. 20th term of geometric progression is a r power 19. So which means a is 3 and r is 1.25 power 19. So this is the first term we have to consider. The formula for finding out sum to n term is a 1 minus r with power n divided by 1 minus r. We can take out the sum for 12 terms as a can be considered as 3 into 1.25 with power 19, 1 minus 1.25 with power 12 upon 1 minus 1.25. So we will get the answer as 1128.4.23, which will be rounded off to the nearest integer is 11,284, 11,284. Another way is that you take out the sum of first 19 terms and then take out the sum of 31 terms and then subtract those. Or you can find out sum of 19 terms, which will be equal to, in that case, you have to consider 3 as a, 1 minus 1.25 with power 19 divided by 1 minus 1.25, which is equal to 820.67. And we'll take out the sum of 31 terms, which is equal to 3 into 1 minus 1.25 with power 31 divided by 1 minus 1.25, which is equal to 12,104.90. So when we will subtract, we will get the sum of 12 terms, S31, sum of 31 terms minus sum of 19 terms. So it will be 12,104.90 minus 820.67. So which will be equal to 11,284.23, and which will be rounded off to integer as 11,254. Part B. An arithmetic progression has first term 5 and common difference 3. The sum of the first 5 n terms is 23 times the sum of the first n terms. Find the value of the positive integer n. We have a is equal to 5 and d is equal to 3. Sum of first 5 n terms is 23 times the sum of the first n terms. So we will take out sum of 5 n terms, which is equal to 5n upon 2, 2a, which is 5, plus n minus 1. So n is 5n here, 5n minus 1 into 3. So when we will simplify it, we will get 5n upon 2, 10 plus 15n minus 3, which will be finally simplified to 15n plus 7. Now we will take out sum of first n terms, which is equal to n upon 2, 2 into 5, plus n minus 1 into 3. So we have n upon 2 into 10 plus 3n minus 3, which is finally n upon 2, 3n plus 7. Sum of 5n terms is equal to 23 times sum of n terms. So we can write here 5n upon 2, 15n plus 7 is equal to 23n upon 2, 3n plus 7. We can cancel out 2 here, we can cancel out n here, because the value of n cannot be 0. So 5 multiplied by 15n is 75n plus 35 is equal to 69n plus 161. 75n minus 69n is equal to 161 minus 35. So 6n is equal to 126. N is equal to 21. Question number 10, part A. A particle P travels in a straight line so that t seconds after leaving a fixed point O, its velocity v meter per second is given by v is equal to sec square t upon 2 minus 1 for t is greater than or equal to 0 and less than or equal to pi upon 2. And v is equal to 2 upon pi into pi minus t for t is greater than pi upon 2. Complete the velocity time graph for the first pi seconds of the motion of particle P. So the first part of the graph is already drawn. For the second part, we have to consider this equation v is equal to 2 upon pi minus t. So if we will substitute here t as pi upon 2, we will be getting 2 minus 1, which is equal to 1. So this point is already here. Then when we will substitute here 3 pi upon 4, we will be getting 2 minus 3 upon 2, which is equal to 1 upon 2. So we have this point over here. And when we will substitute here pi minus pi will be equal to 0. So velocity is 0. So we will have this point over here. So we can draw the graph. Part 2. Find the distance in meters traveled by P in the first 5 seconds of its motion. You must show all your working. So first of all, we will find out the distance from 0 to pi upon 2. Distance from 0 to pi upon 2 is the area under the curve, which we can find out by integrating v is equal to sec square t upon 2 minus 1, and limits can be taken as 0 till pi upon 2. For the distance from pi upon 2 to pi, we can find out area of triangle. So the distance from 0 to pi upon 2 is equal to integral of x square t upon 2 minus 1 dt. When we will integrate it, we will get 10 t upon 2, and then we will divide it by the differential of this, which is 1 upon 2 minus t with limits pi upon 2, 0. When we will simplify it, we will get 2 10 t upon 2 minus t with limits pi upon 2 and 0. Now, once we will substitute, the value of t is pi upon 2, 210. When we will substitute here pi upon 2, it will become pi upon 4 minus pi upon 2 minus, we will substitute here 210, 0 divided by 2 minus 0. So tan pi upon 4 is 1. So this will become 2 into 1 minus pi upon 2 minus tan 0 will become 0. So 0 multiplied by 2 is 0. And here we have 0. So it will be minus 0. So finally we have 2 minus pi upon 2. Now we'll take out distance from pi upon 2 to pi. For this, we will take out the area of triangle whose height is 1 and whose base is pi minus pi upon 2, which is pi upon 2. So half into 1 into pi upon 2, so which is pi upon 4. So the total distance is equal to 2 minus pi upon 2 plus pi upon 4, which is equal to 2 minus pi upon 4. Part B. A particle Q travels in a straight line from a fixed point O. At time t seconds, its displacement from O, s meters, is given by s is equal to 4 minus e power 2t minus 3 e power minus 2t upon 2. Part 1. Find the value of t when Q is at instantaneous rest. Instantaneous rest means velocity is equal to 0. Give your answer correct to 4 significant figures. Now, first of all, we can simplify this to 4 upon 2 minus e power 2t upon 2 minus 3e power minus 2t upon 2. So this will become 2 ones are 2, 2 twos are 4. So now we need to take out velocity so that we can substitute velocity as 0 and find out the value of t. So velocity is equal to ds upon dt. When we differentiate displacement, then we get velocity. So when we will differentiate this, it will become 0. When we will differentiate e power 2t upon 2, e power 2t will remain as it is. And when this will be differentiated, we will get 2. So we will write it over here. Minus e power minus 2t will be written as it is. When we will differentiate minus 2t, this will give minus 2. So we will have velocity is equal to this and this will be cancelled out. Minus e power 2t. Minus minus will become plus. And this 2 and 2 would be cancelled out. So it will be 3 e power minus 2t. So when we will take velocity as 0, it will be 0 is equal to minus e 2 power t plus 3 e power minus 2t. We will take this e power 2t on this side. So it will become 3 e power minus 2t. We'll take it to the denominator. It will become e power 2t. We will do cross multiplication. It will become e power 2t square is equal to 3. So e power 4t is equal to 3. We'll apply ln on both sides. Ln e 4t is equal to ln 3. So 4t ln e is equal to ln 3. Ln e is equal to 1. So 4t is equal to ln 3. and t is equal to ln 3 divided by 4. So t is equal to 0.27465, which when rounded off to 4 significant figures, it will become 0.2747. Part 2. Find the distance traveled by Q in the first 0.5 seconds. So we can make here the table. We can take the time 0 and then 0.2747, at which the velocity is 0, and then 0.5. We will take out S by substituting in the equation. We have here S is equal to 4 minus e power 2t minus 3 e power minus 2t upon 2. So when we will substitute t as 0, we will be getting here as 0. When we will substitute t as 0.2747, we will be getting 0.26794. Then when we will substitute 0.5 in this, we will be getting 0.0890. So then we will take out the difference from here till here, which will be minus 0.17890. The difference from here till here, it is 0.26794. For the distance traveled by Q, we can add 0.26794. As this is a displacement, so it is negative, we have to consider it is as positive 0.17890. So we will get 0.4468